Hello everyone, welcome to the 20th video on Snowpro core certification series. In this video, we are going to look about Snowpipe and Snowpipe streaming API from Snowflake. So far, as the part of the data loading, we discussed about the bulk data loading options using copy into and other statements. But as the part of this video, we are going to discuss about micro batch streaming options using Snowpipe and continuous streaming options using Snowpipe streaming APIs. Snowpipe enables you to load the data from files as soon as they are available in stage. Again, an evidence statement. Load the data from the files in the micro batches. We saw this detail to a greater extent in the previous video itself, making it available to the users within minutes. So the ideal Snowflake recommendation is once a minute. So processing the micro batches once a minute using the Snowflake is the ideal one, rather than manually executing the copy statements on a schedule to load the larger batches. As simple as it is, Snowpipe is all about micro batch streaming. Snowpipe uses the serverless compute model. Users can initiate any size load without managing a virtual warehouse. This is the ideal differentiation between the normal copy into and the Snowpipe. Snowpipe comes by itself with the compute in the form of the serverless compute model. The data is loaded according to the copy statement defined within the referenced pipe. So the how the data loading is going to happen is based on the copy statement which we are going to provide within the Snowpipe. A pipe is the named first class Snowflake object that contains a copy statement used by the Snowpipe. Again, the same evidence statement. The copy statement identifies the source location of the data files, that is a stage, and the target table. So we will provide the source location and the target table in the copy statement of the Snowpipe, so that it will take the data and it will load it into the target table. More or less similar to the copy into statement which we discussed earlier, but the compute model is completely different for Snowpipe. Snowpipe uses the serverless mode, meaning no need to manage any of the warehouses. Snowflake by itself will provide you the compute and it will charge you based on the compute which you are using for the Snowpipe. All the data types are supported, including the semi-structured data types such as JSON and Avro. So all structured data types are supported, including the semi-structured data types like JSON and Avro is also supported. Now there are two ways by which you can implement the Snowpipe. One way is by using the cloud messaging systems such as SQS queues or Azure Event Grid or GCS PubSub, right? So these are all various cloud native options which are available to us to queue the data, meaning to send the data in the form of the near real-time queues. Now first we are going to discuss about automating Snowpipe using the cloud messaging systems, which are, as we already discussed, SQS and Azure Event Grid and GCP's PubSub. Automated data loads leverage event notifications from the cloud storage to inform Snowpipe of the arrival of the new data files to the load. As simple as it is, in any of the cloud storage systems, say like AWS S3, where once we can place the data file, automatically we will be having the option to trigger the next option, that we call it as the event notification system. S3 is having lot of event notifications. One such notification is the SQS queue. Obviously we will be utilizing AWS Lambda to do lot of things. Say once my file got loaded into the S3 bucket, one Lambda will get triggered, that Lambda will load it into some other place, or it will copy that file into some other place. Lot of options we can do using Lambda. That is one thing which is predominantly used across the industry. But for this use case, once the S3 data is landed on the S3 bucket, one SQS queue will be triggered. That SQS queue will trigger the Snowpipe in Snowflake. As simple as it is. Snowpipe polls the events notifications from the queue. This is what which we discussed earlier. By using the metadata in the queue, Snowpipe loads the new data files into the target table in a continuous serverless fashion based on the parameters defined in the specific pipe object. Again, everything is self-explanatory. Now you can see this diagram is pretty evident, we discussed in a greater detail as well. So the data is landed in GCP storage, then you can utilize GCP PubSub. Once the data is landed into Amazon S3, we can wrap it in the SMS message, and then we can trigger the SQS queue. Similarly, in the Azure blob, you can trigger the Azure event grid. Now completing this diagram using this automated Snowpipe, here is the complete end-to-end diagram. This is one of the cloud storage which is represented here, and then we can do the event notification. Then we will ingest the data into the any of these forms of ingest queues which is mentioned here. Then we can do the integration to the Snowflake's external stage, right? This integration is pretty evident, we can do it using lot of factors. And once the data is there in the Snowflake's external stage, we can derive the copy into command using Snowpipe. So Snowpipe provides the compute. Once that is done, the data will be loaded into the target table. So this is a near real-time continuous fashion, meaning once the data got loaded into cloud storage in mini batches, automatically this event will be triggered, automatically the queue will be triggered, automatically the data will be available in external stage, automatically the Snowpipe will trigger the copy into command, and the data will be loaded into the target Snowflake tables. Now we are going to discuss about the examples for the automated cloud messaging system. What are all the ways by which we can do? First of all, we need to create the integration, that is which we discussed in the earlier diagram as well. How we can create the integration is using this. Here you can see create notification integration enabled equal to true, type equal to queue. This is a kind of the Azure event grid notification. First we create this notification integration. Once that is done, then we will create the Snowpipe using the create pipe command with again auto ingest equal to true. Auto ingest equal to true tells Snowflake that we are ingesting the data via the cloud messaging systems, and the integration which we already created is noted here. Copy into the target table name from the external stage which we created as the part of it, and the file format is equal to JSON. Here we are just trying to load the semi-structured data via the Snowpipe option. Now moving on to the second option of loading the data via Snowpipe, which is by calling the REST API endpoints. So instead of using cloud-based messaging queues, you can very well use the API methodology to call the Snowpipe via the API, and also you can ingest the data. So what we can do, client app can call the REST endpoint, which is the insert files REST API endpoint, with the same name of the pipe object and the list of the data file names. We are going to discuss in greater detail via a diagram. If a new data files matching the list are discovered in the stage referenced by the pipe object, they are queued for loading. As simple as it is. Snowflake provided compute resources load the data from the queue into the Snowflake table based on the parameters defined in the pipe. So instead of cloud messaging queues, this is the other way of calling it via REST endpoint. This is an interesting picture which I got from the Snowflake documentation. This is one of the biggest pictures in the Snowflake documentation. For easy understanding, I just make that horizontal picture into I just made that vertical picture into an horizontal picture. Here, first the data files are available. Once the data files are available, we will do a continuous data inflow mechanism. We need to utilize any of the third-party tools to ingest the data into that internal Snowflake stage, or external stages, or external blob storage, or external GCS stage. So any of these stages we can do the continuous data inflow ingestion. Once these files are in these stages, then we can utilize the insert files API endpoint, and it will call the REST API endpoints here. That REST API endpoint will insert the files into the ingest queue. Again, it will be consumed by the Snowpipe, and utilizing the copy command, it will load the data into the Snowflake table. Here, what you can do from your local desktop computer as well, you can utilize the same REST API endpoint referencing the pipe which you already created. You can insert the data via that. Then automatically it will be taken into consideration by ingest queue, and then it will be loaded via the Snowpipe. So calling the REST API is also the another option which is available within Snowpipe. The next thing is when to use Snowpipe REST API and when to use Snowpipe Auto Ingest. Auto Ingest is all about cloud-based messaging. So what are all the differences between both? This is available, the REST API is available to use for internal and external stages, whereas the Auto Ingest is available to use only for the external stages. Important point to note. Manually, you can call the REST API endpoint with the name of the pipe and list of the file names. This is again an additional opportunity, but here a notification is received from the cloud provider when a new file arrives. As simple as it is, it's a completely automated fashion. Automatically data loaded into cloud storage, the entire pipeline will be triggered, but here you can manually call it. This is an example which we saw. It passes the list of the files in the storage location. It processes the new files when it is awakened. As simple as it is, again it is very self-explanatory. Now we are going to discuss about Snowpipe versus bulk loading. This is pretty evident, but there is a detailed descriptions which are available in the Snowflake documentation. So we must have to see what are all the ideal differences with respect to varieties of features. Say like authentication, say it like load history, say it like transaction, say it like compute resources, and also for the cost. So you can see for this feature how it is differentiated between the bulk data load and also with the Snowpipe. So here if you see for authentication, it relies on the security options that are supported by the client for authenticating and initiating the user session. It is pretty straightforward, say using Snowsql or using your own native methods of authentication to authenticate yourself into Snowflake. But here if you see for the Snowpipe, the auto ingest is pretty evident. It is completely automated pipeline. When you are calling the REST API endpoints, you require a key pair authentication with the JWT, which is the JSON Web Token. JWTs are signed by the public private key pair with RSA encryption. Again, you must be aware of what is the public private key pair, right? So this is the differentiation. When it comes to the load history, if you see the metadata of the target table is stored for 64 days. We already saw this as the part of the earlier video in copy into loading the uncertain files. So the metadata history is maintained for 64 days, available upon completion of the copy statement as the statement output. Pretty evident. Here if you see the metadata of the Snowpipe is stored only for 14 days. Important thing to note, there is a differentiation here. Must be required from the Snowflake via the REST endpoint, SQL table function or account usage view. That is the difference. Moving on to the transactions, loads are always performed in a single transaction. Data is inserted into table alongside any other SQL statement submitted manually by the users. This is again pretty evident. At the same time, while you are doing the data loading, there are other statements which can be executed via the same warehouse or via the different warehouse as well. But here in the Snowpipe, loads are combined or split into single or multiple transactions based on number and size of the rows in each data file. Rows are partially loaded files based on error copy option setting can also be combined or split into one or more transactions. That is the difference in terms of the transactions between bulk data load and the Snowpipe. Moving on to compute resources, we are already aware of this. For bulk data load using copy into, we need an user specified virtual warehouse to execute it, whereas in Snowpipe everything is done via the Snowflake's internal serverless compute model. Snowflake manages the compute resources for you. We are going to discuss about the billing, how the Snowpipe billing is going to happen in the subsequent places. Coming to the cost, it is built based on the virtual warehouse. As you all know, as virtual warehouse is needed for bulk data loading, the time and the number of the files which it got processed based on the various factors which we already discussed. Based on those things, the charging for the bulk data load will be there. But when it comes to the Snowpipe, built according to the compute resources used by the Snowpipe warehouse while loading the files. Again, it is not pretty straightforward. Snowflake by themselves manages the compute for you and they will provide you the billing for Snowpipe. As simple as it is. Now we are going to discuss about the Snowpipe billing. How Snowflake is going to bill us for the Snowpipe. Snowflake provides and manages the compute resources automatically growing or shrinking capacity based on the current Snowpipe load. So what is the meaning of this statement? Snowflake manage everything for you. No need to do anything specific for the Snowpipe. Accounts are charged based on their actual compute resource usage, not like a virtual warehouse which consume credits when it is active. So whenever a virtual warehouse is active, your Snowflake credits will be consumed, but here for the Snowpipe it is not the case. Snowflake will do all the manipulation work for you, and finally on the bill they will provide you the Snowpipe cost. Snowflake tracks the resource consumption of the loads for all the pipes in an account with a per second per core granularity, as Snowpipe actively queues and process the data files. As simple as it is, per core refers to physical CPU cores in the compute server. The utilization recorded is then translated into familiar Snowflake credits which are listed on the bill of your account. In addition to the resource consumption, a overhead is included in the utilization cost charged for the Snowpipe, charged 0.06 credits per 1000 files. So there is an additional cost apart from your regular cost. It is for every 1000 file processed, Snowflake will be adding 0.06 Snowflake credits. Then estimating the Snowpipe charges, this is something which is very interesting to know. Given the number of factors that can differentiate Snowpipe loads, it is very difficult for Snowflake to provide the sample cost, the exact statement which I got from the Snowflake documentation. So Snowflake is telling you to experiment it by performing typical sets of loads to estimate the future charges. So there is no clear-cut sample costing estimates which is available within the Snowflake documentation itself for the Snowpipe. So how we can see the Snowpipe's utilization? It can be done via the pipe usage history table function on information schema, or via the pipe usage history view in the account usage. As usual, you all know information schema and account usage holds most of the tables which are needed for the billing related purposes. Here is the query. This query will provide you the Snowpipe's cost history by day by object over last 30 days broken out by day. So as simple as it is, if you see pipe usage history is the table which is used here. So sum of credits, they are doing it with the pipe name and they will be grouping it with the date and pipe. So obviously you will get this relevant information. This is the other one, average daily credits consumed by the Snowpipe grouped by the week over last year. Why this is needed? This is useful to identify the anomalies. If you see there is a sudden spike in the Snowpipe usage, or there is the sudden down in the Snowpipe usage, then it is an easy indication for you to understand there is a problem in there with number of files or with number of the Snowpipe which is used over there. So these are all some of the important queries which you can utilize using the pipe usage history table function or view to understand the Snowpipe credit usage. Here is the next interesting topic, which is the Snowpipe streaming API. This is all about real-time data streaming into Snowflake ecosystem. This is slightly different from the Snowpipe way by which we will be doing it in the micro batches. Here we are going to see how the Snowpipe streaming API is going to be used. Now the Snowpipe streaming API is a low latency loading for streaming data rows into the Snowflake Ingest SDK and your own managed application code. What they are trying to say, this is a software development kit which is provided by Snowflake. So via code you can add this SDK into your code and you can directly stream your data into Snowflake. This API removes the need to create the files and load the data into the Snowflake tables and enables the automatic continuous loading of data streams into Snowflake as the data becomes completely available. So again, an evident statement to understand, there is no necessity to create intermediate stages when you are streaming the data using this API. This architecture results in a very low latency and lower cost handling for real-time data streams. This API is intended to complement Snowpipe, not not to replace it. Again, an interesting statement to know. Since it is an real-time streaming, you can use this as the complement for the Snowpipe as well. Use of the Snowpipe streaming API in streaming scenarios where the data is streamed via rows. For example, Apache Kafka topics, instead of writing it into files. For better understanding, I just put together this picture. Let us try to understand this picture here. Say if you are using the Snowpipe with auto ingest, obviously the files will be staged in any of the Snowflake stages, say it like an external stage or internal stage. Then from there only you will be pushing the data into the staging table. But here, with the use of this client SDK or the Snowpipe streaming API, you can directly push the data from any of the streaming systems like Kafka into the Snowflake. That is the ideal example which is represented in the statements as well there. This API will fit into your ingest workflow that includes the existing custom Java application that produces or receives the records. So again, as a coding point of view, you need to ingest this specific code into your existing application. How this API does the ingestion? This API does the ingestion via something called as a channel. Here you can see channel 1 to channel 1n. So using one channel, you will be loading table 1. Using another channel, you will be loading table 2. Here you are seeing the another client application, client 2, that is using different channel to load the table 3. So via channels, the streaming API will be pushing the data into the Snowflake tables. That is what it is represented here. A channel represents a logical named streaming connection to Snowflake for loading the data into table. A single channel maps to exactly one table in Snowflake. However, multiple channels can point to same table as well. The client SDK can open multiple channels to multiple tables. However, the SDK cannot open channels across accounts. This is again an interesting thing to know. So as simple as it is, for the streaming use cases, you can very well utilize the Snowpipe streaming APIs. So yet another $1 billion question. We need to know what are all the differences between Snowpipe and Snowpipe streaming. We are already aware of to some extent, but let us see. Again, from the better Snowflake documentation, there is a lot of information which is available for us to consume. First, from the category side, if you see, form of the data to be loaded in the Snowpipe streaming, which we already saw, it will be in the form of the Kafka rows or rows. But here for the Snowpipe, it will be in the form of files. So if existing data pipeline generate the files in blob storage, use the Snowpipe instead of the API. As simple as it is, but predominantly it will be processed in the form of the files. That is very evident in the previous diagram which we saw. Third-party software requirements, it's a custom Java application. As we already saw, code wrapper for the software to ingest the SDK. So you need to write the Java code to ingest the data via the Snowpipe streaming. But here there is no necessity for the third-party software requirements. Data ordering insertions within the each channel is possible. So as we already know, the data is ingested via channels within the Snowpipe streaming, but within the channel we will be having the way to order the insertions. But here in Snowpipe, the ordering is not supported. Snowpipe can load the data from files in an order different from the file creation timestamps in the cloud storage. So that is something which is very important to know. Load history, here the load history is recorded in Snowpipe streaming file migration history view of account usage. Here in this case, the Snowpipe load history is recorded in the normal load history table of load history view of account usage and copy history function in the information schema. Finally, the pipe object does not require a pipe object. For Snowpipe streaming, there is no requirement for the pipe object. The API writes directly into the Snowflake target tables, but here for the Snowpipe to work, you need to create a pipe object that queues and loads the staged file data into the target files. Again, it is very evident. Now finally, before closing this specific video, I just wanted to show a simple example of using Kafka with Snowpipe and using Kafka directly using Snowpipe streaming API. The top portion of the diagram is using Kafka with Snowpipe. Here you can see there are different Kafka topics. Those Kafka topics are put into the Snowsync task using put and pre-commit. Here you can see all those details will be pushed into an internal stage. Then from the internal stage only it is getting pushed into the Snowpipe, which will write it into the Snowflake table. Whereas if you can see at the bottom for the Snowpipe streaming plus Kafka connector, instead of staging those things into files, you can directly utilize the channels. Here the channels are directly streaming the data into the Snowflake table. That is the reason why this is the ideal option for your continuous real-time streaming applications. With this we came to end of this video. I hope this video has been informative for you. Please do write lot of comments. That will be very much required for me to enhance the course contents. Thank you very much for watching this video. As usual, I will be placing all the relevant Snowflake documentation links in the description of this video as well.